Alright, so in this video we're going to learn how to use the reduction formula. This will be, I'll have four different examples. The difference in the different examples is the alpha. It'll be in different quadrants in each video. I'll have a video where alpha's in the first quadrant, another one that's in the second, then another one third, another one fourth. So you can check them all out. So what we're doing is we have sine x plus cosine x, and we have a coefficient for each one here. And what we're going to do is we're going to rewrite it as a single sine function. Instead of having two trig functions added together, it's just going to be a single one. So if alpha is an angle in standard position whose terminal side contains AB, then a sine x plus b cosine x is equal to, and this is going to be the square root of a squared plus b squared times sine of x plus alpha for any real number x. So we know how to get this number here in front of sine. X is just going to be x, and then we've got to figure out how to find alpha. Now, depending on what textbook you're using, or how your teacher tells you to do it, there's different ways to find alpha. There's also, you've got sine alpha is equal to b over the square root of a squared plus b squared, and you've got cosine alpha is equal to a over a squared plus b squared. Okay, you can use either one to find alpha. I just always like to use tangent alpha as b over a. And look, all this is, look, if you have an angle here, and it doesn't matter what quadrant it's in, and say it contains, the terminal side contains the point AB, so we know this is A, this is B, okay? And look, this side here is the square root of a squared plus b squared. See, Pythagorean Theorem. And if this is theta, I mean, look, that's where these come from. Okay, so if we call this a squared plus b squared, if we call that, say, r equals that, okay, you probably recognize this. Okay, we can say r equals a squared plus b squared. That's the hypotenuse of this right triangle. Here's your angle. This is the side opposite, and this is the side adjacent. So we know that what tangent alpha is what opposite over adjacent, b over a. Look at this. The sine, well, I know I'm using theta here, but it's the same thing. Theta alpha, doesn't matter which angle you use. But look at this. The sine of the angle, what's sine? Opposite over hypotenuse. You see that? Opposite over hypotenuse. And look at cosine. The cosine of this angle is adjacent over hypotenuse. So that's all that is. Okay, so whichever your teacher tells you to use, just use whichever one. Okay, but like I said, in these videos I'll just use tangent alpha equals b over a. That, to me, that's the easiest one to do. And plus a and b are given to you, so you don't have there's not a chance of, in case you make a mistake calculating this, then your angle will be wrong also. So just use what's given to you there. Okay, all right, so let's go ahead and get started on the example. All right, so we got example 3 here. So it says use the reduction formula to rewrite 1/2 sine x minus square root of 3 over 2 cosine x in the form a sine x plus c. Now I know the formula for this in front here, it had this was square root of a squared plus b squared. Well, they're just using a instead of writing all that down. Okay, but a is this, and then c, that's like the alpha in the formula. All right, so, well, let's go ahead first and identify little a and little b. So a is 1/2, and B is negative the square root of 3 over 2. Okay, so we got A and B. Now let's find this big A here. Well, that is equal to the square root of A squared, so that's 1/2 squared, plus B squared, so that's negative square root of 3 over 2 squared. And so that's going to give us the square root of, let's see, what is that, 1/4 plus square root of 3 squared is 3, 2 squared is 4. Well, that turned out nice, didn't it? 1/4 plus 3/4 is 4 over 4, which is 1. Square root of 1 is 1. Okay, so A here is 1. Now we need to get tangent. Alright, so let's get tangent C, and that's B over A. So that's negative square root of 3 over 2 over 1/2. And so tangent C is, well, that's what, negative square root of 3 over 2 times the remember, this divided by this is this times the reciprocal. And so we get tangent C is equal to negative square root of 3. Alright, so what we've got to do here is we've got to figure out which quadrant our angle's in. Well, remember in the formula that it says that the terminal side of the angle passes through the point AB. So if we plot the point AB, well, that's 1/2 negative square root of 3 over 2. So we can see our angle is in the fourth quadrant. That's C. Well, what we need to do is what? Find our reference angle. And I just use this mark here to represent the reference angle. Some books use different marks. The one I teach out of, it uses this prime here, C prime. Well, in order to find the reference angle, remember, anytime you take the sine, cosine, or tangent of a reference angle, it's always equal to a positive number, because remember, your reference angle is a first quadrant angle. So what I like to do is I'll rewrite this when it's negative like this, and I'll change this to positive square root of 3 so I can go ahead and find my reference angle. So this is just how you find your reference angle. You set it equal to the positive, and so I get my reference angle. Well, what is this? The tangent of what is square root of 3? Well, that's what? 60 degrees. Okay, so there's my reference angle, 60 degrees. Well, what is C? C is equal to what? 360 minus the reference angle. 360 minus 60, which is 300 degrees. So there's C. Alright, so I'm going to get 1/2 sine x minus square root of 3 over 2 cosine x is equal to A, which is 1, so we don't need to put anything there because it's understood there's a 1, sine of x plus 300 degrees. Now, you could do this in radians, so let's look at that. So if this were in radians, this would be what? Pi over 3, right? So our reference angle would be pi over 3 instead of 60 because we're in radians. So our angle C would be what? 2 pi minus pi over 3, because when we go all the way around, that's 2 pi, subtract off the pi over 3, and that is what? 5 pi over 3. And so we could write this as sine x plus 5 pi over 3. So, whichever one your teacher wants you to do, radians, degrees, there's both of them. So, hope this video helped. Give me a like, share, and subscribe, and check out my other videos, and thanks for watching.